Hi there, welcome to highschoolmaths.co.uk. Today we're going to be looking at how you factorise using a difference of two squares. It's a fairly simple process, and what you have to kind of look at is the wording of the question, the actual title here. It's a difference of two squares. So difference means we're looking for a subtraction. So it's got to be a takeaway in the middle, and you'll notice each question here is a takeaway in the middle. It's two terms, so it's a difference of two terms. So if there's three terms, this isn't going to work. And the terms have got to be square terms. So a difference of two squares. So that's where the title comes from. Now if we look at the first example here, you'll notice that it is a difference, subtract in the middle. The first term is x squared, so that's a square term. The last term is 4, which is 2 squared. So it's a difference of two squares. The way we factorise this is we look to have the same terms at the beginning and the same terms at the end of the brackets. So we put an x at the beginning and an x at the end, because x times x gives you x squared. At the end of the bracket, we've got to have 2 times 2, because 2 times 2 gives you 4. Now what we want, when we multiply out two brackets, we usually get a middle term. What we want is for that middle term to cancel itself out. So we want to put a plus in one bracket and a minus in the other. What that'll do is cancel out the middle term, because we'll have, if we multiply this out, we'd have plus 2x and minus 2x, which is 0. And you end up with just x squared minus 4. So if you multiply this back out, you would end up back at the original expression, which is what you're looking to do when you're factorising. For the second example, again, we're writing down our two empty brackets. It is a difference of two squares, so a and a at the beginning, 5 and 5 at the end, and a plus and a minus. Now as long as one of the brackets is plus and one is minus, that's fine. You could have minus in the first bracket and a plus in the second. You'll get the same answer. Third example, again, we've got a difference of two squares here. When you've got numbers, you should always check to see if there's a common factor first. So 9 and 16 aren't in the same times table, so we can open up our two brackets and jump straight into the difference of two squares, but we should always look for that common factor just in case. Now, if we're thinking what gives us 9a squared, it's 3a and 3a, because 3a times 3a is 9a squared. And remember, the terms have got to be the same at beginning and end. To get 16b squared, it's got to be 4b and 4b. And again, a plus and a minus in the middle, and that's that factorised fully. Second last question, and this is where it's going to get a little bit trickier. This is quite common in exams. Again, we'll look at it, and you've got to think, first of all, is there a common factor? If there are two numbers, we've got to look for that, and there is. These are both in the 2 times table. So we can take out 2 as a common factor, just as a single bracket, 2 bracket x squared minus 4. And then we have to look at what's left inside the bracket and see, can we factorise that a little bit further? And then if we look at the terms here, it's again, if we just focus on the difference of two squares, you'll notice that it's x squared minus 4 inside the bracket, which is what we had over here at the very beginning. So that can be factorised a little further. So this one bracket here is going to become 2 empty brackets, and we're looking, you can kind of just ignore the 2's just now. We're looking to see what gives us x squared for the beginning, so x times x, 4 at the end, well that's 2 times 2, and a plus and a minus. Same idea with the final example here. You'll notice here that these are actually both squared terms, and some people might forget to look for the common factor first, because 16 and 36 are both squared numbers. But you've got to look for that common factor, and they're actually both in the 4 times table, so we want to take that 4 as a common factor out first. That leaves us with 4x squared minus 9y squared. And again, I'm going to squeeze this in here. The bit inside the bracket, the terms inside the bracket, or the expression, sorry, inside the bracket is a difference of two squares. 4 is a square number, 9 is a square number, and it's a takeaway in the middle. So at the beginning, we've got 2x times 2x to give us 4x squared. At the end, 3y times 3y to give us 9y squared, and a plus and a minus to complete the factorisation. So that's the different variations of difference of two squares. Sometimes you'll get a question with a difference of two squares on its own. Sometimes, and quite commonly, it'll be a common factor, then a difference of two squares. So something to watch out for there. Hopefully you found that helpful. For other resources and videos, please visit highschoolmaths.co.uk. And if you liked the video, don't forget to click that like button and subscribe. And please remember to share the video. Thanks for watching, and have a mathemagical day.